Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss the problems related to the Module 5 that is based on the concept of multiprocessors. Explain interprocessor communication and synchronization. In the multiprocessor system, more than one processor can be employed to support the parallel execution of the task. So when parallelly or concurrently more than one processor is executing, how these processes can be communicated, coordinated, synchronized can be discussed under the concept of interprocessor communication and synchronization. The various processes in a multiprocessor system must be provided with facility for communicating with each other. The communication path can be established by giving the portion of the memory or a common input-output channel. So, a bus has to be established to connect the processor with the memory. So, the shared memory is the one of the technique for interprocess communication. The sending process structures a request, a message or a procedure and places it in the memory mailbox. So, the processor that want to communicate has to structure a request. The status bits can be altered residing in the common memory. So, the receiving processor can regularly check the mailbox. The response time of this procedure can be time consuming. The receiving process can periodically check the mailbox. So, to avoid this, an interrupt signal can be used to alert the receiving process that a message can be available. So, here, if this is the memory unit of the processor and some portion of the memory can be used for the shared memory. And this is one CPU and this is the another CPU. So, these two CPUs must communicate with the processors. So, here the CPU can make a message and can store the data or message procedure in the shared memory. For which CPU this message can be created, that the CPUs that are involved and connected with this shared memory can regularly monitor the mailbox of those concerned processors, that any messages is related for that processor is placed in the shared memory. So, that is status bits residing in the common memory can be altered, and so that after continuous verification of mailbox of that particular processor can recognize the message pertaining to that processor. So, this is a time consuming. So, the alternative process for this is creating an interrupt signal for the CPU that involves in the communication to make an alert that the message is available in the shared memory. So, in addition to the shared memory, a multiprocess system may have other shared resources also. So, to prevent conflict of using of shared resources by several processors, there is a provision of assigning resources to the process with the help of operating system. So, there are three organizations employed for this purpose. One is master-slave configuration. Second one is loosely coupled configuration. Third one is distributed operating system. What is master-slave configuration? So, multiple processors that are connected with the main memory, one of the processor can be act as the master and the other processors can be act as the slaves for this master. The master processor itself has the major control over the inter-process communication. The master processor can schedule the task between the slaves. So, the master processor is to manage the entire system consisting of files, devices, main memory, and the slave process. So the status of all processors, scheduling of the work for the slave processes is executed by the master master processor itself. The master processor is also responsible for storage management. The shared memory management can be done with the help of a master processor. So this type of configuration is suitable for computing environment where two-tier architecture can be used for the applications, the front-end and the back-end processors. So the disadvantage is it is reliable like that of single processor. If master processor fails, the entire system fails. And it creates more overhead in the task scheduling. And after completion of each task by the slave processor, it frequently interrupts the master processor. So these are the disadvantages of this configuration. The second configuration is loosely coupled configuration. So in this, each processor can execute independently operating system routines and referred as separate operating system organization. So each processor is control its own resources and their own command management tables can be available. So each processor can also communicate and cooperate with each other. So when a job is given, it is assigned to one processor and that processor can execute and responsible for the completion of that task. So there must be a global table to indicate which processor has given specific task. So this is the architecture of loosely coupled configuration. Here these are the multiple processors and each processor can have its own main memory as well as I/O devices. And these processors can communicate and coordinate with other processors. If a task is given to a particular processor, the execution can be completed by that processor itself. So what task is given to which one? A global table can be maintained, centralized table, so that the scheduling of tasks can be updated in that table. So this type of organization is the loosely coupled configuration. Next one is symmetric configuration. In symmetric configuration, processor scheduling is decentralized. So the distributed environment can be configured in the system symmetric configuration. A single copy of operating system and a table listing each process and its status is stored in the memory, common and accessible to all processors. So global table can be maintained so that the scheduling of task and operating system can be available at that global table, so that each processor can use the algorithms to decide which job to run next. So here main memory and I/O devices, all processors are connected for the I/O devices and the main memory. So a single copy of operating system and the task scheduling global table can be maintained by this configuration. What are the advantages of this configuration? It is more reliable than the loosely coupled configuration and uses the more effective way of utilization of resources. It well manages the load of the job. And if one processor fails, the other processor can bear the load of that processor. So, graceful degradation can be available. So, the disadvantages of this configuration is it increases the chances of conflicts between the processors and also a most difficult configuration to implement. So, how processors are communicated with various configurations we discussed. How inter-processor communication can be synchronized. How they can share the common data and resources, the common memory. So, the instruction set of multiprocessor contains some specialized instructions to communicate and synchronize between the cooperating processes. So communication refers to exchange of data between different processes. Synchronization refers to special case where the data used to communicate between processor is control information. So the sequence at which the processors can access the data can be defined with the help of synchronization mechanism. And also it must enforce that correct sequence of processes to ensure mutual exclusive access to shared writable data. When common data is modified, then it may generate the data inconsistency problem. To avoid that, mutual exclusion and critical section techniques can be employed. So what are the mechanisms for process synchronization? Means low-level primitives to implement directly the synchronization. These primitives can provide the basic mechanism to enforce the mutual exclusion, and they can the hardware mechanisms that can provide the binary semaphore for process synchronization. Now we have to discuss what is mutual exclusion, what is semaphore. What is mutual exclusion means a properly functioning multiprocessor system must provide a mechanism that will guarantee orderly access to shared memory and other shared resources. So the processor with this mutual exclusion only can enforce the accessing mechanism of common resources. So this is necessary to protect the data from being changed simultaneously by two or more processors. So how this can be possible means with the help of critical section. So critical section is a program sequence that must complete execution before another processor accesses the same shared resource. So we can discuss the mutual exclusion and critical section with one example. You can consider in a shopping mall the trial room as the example. So the trial room is the critical section. And the two processors can use this critical section. That is, boy A and girl B want to use this critical section or the trial room. How they can has to identify whether that room is vacant and occupied with the status. So here this is a binary variable that can be used to control the access of the critical section. So this status is the semaphore. So here whenever it is vacant, the boy and girl want to use it. So the order at which resource can use the critical section can be indicated with the mutual exclusion fashion. So the boy entered into the room so that the status can be updated here occupied. So that the girl want to use that critical section by observing the status of the semaphore occupied can wait until this critical section can be modified as vacant state. So that other processor is using this common resource. So the processor has to wait. So after completion, when the boy completed its task, then he has to come out so that the status can be updated as vacant. So the girl B can know that this processor the critical section is empty, can enter into and use the common resources. In this way, the mutual exclusion, critical section and semaphore can be used for process synchronization. So the semaphore is a binary variable and it is used to indicate whether or not the processor is executing in the critical section. So here in our example, the binary semaphore can contain two states, whether occupied or vacant. So with this, the processor that is want to enter into the critical section, that can identify and notify with the semaphore status. So here in the how to implement this semaphore means with the help of testing and setting semaphore itself in a critical operation, and it must be performed a single indivisible operation. So a semaphore can be initialized by means of test and set instructions in conjunction, okay, with the hardware lock mechanism. So test and set instruction in combination with hardware lock mechanism, the semaphore can be implemented, and the execution of semaphore can require two memory cycles, and the RTL to represent the semaphore is memory semaphore, that status can be returned to the register, and a one value when the critical section is using the status updation can be returned to the location of the memory semaphore. So in this way, the RTL, the semaphore can be represented. So the semaphore can be main means of process synchronization mechanism. Next question is, explain the basic concept of pipelining. So parallel processing is the one of the characteristic of the multiprocessor systems. That means the more than one task can be concurrently executed at the same time in the parallel processing system. This can be achieved by implementing the multiplicity of functional units or through pipelining concept. Pipelining process is implementation technique where arithmetic suboperations or the phases of the computer instruction overlap in execution. So in the pipeline, whether the arithmetic instruction suboperations or the phases of the instruction cycle can be executed in a overlap fashion. So this technique is used to decompose the sequential process into sub-operation. So the main task can be subdivided into segments. Each segment can carry out some specialized sub-operations. Each sub-process being executed in a special dedicated segment that operate concurrently with other segments. So a pipeline can be visualized as a collection of processing segments through which binary information can be flow. So the way of speeding of execution of instructions. So more than one instruction can execute simultaneously with the help of pipelining. So as a summary, a pipeline is overlap execution of multiple instructions. What is the key idea behind the pipeline concept? So breaking the big computational task into small groups. Separate each piece with a pipeline register. It is faster for repeated computations. Pipelining increases throughput. So here more than one instruction executed simultaneously in a unit of time. So the number of instructions that are executed with a pipelining can be increased so that the throughput can be increased. How this can be accomplished, we will observe with an example. Now consider an example, one arithmetic operation that can involve multiply and add operations, a stream of numbers. For example, AI into BI multiplication and plus CI for a stream of numbers 1 to 7. The I value can be 1, 2, 3, 7. So how this can be achieved with the pipeline process? So here the big computational task can be divided into segment in a pipelining concept. So each sub instruction is implemented in a segment within the pipeline. Each segment has one or two registers and a combinational circuit. How these computational tasks can be divided into small segments. The first segment 1 is input the two numbers AI and BI to the respective registers. So AI can be moved to register R1, BI is moved to the register R2. The second segment is multiply and input C. So the A value, B value that are stored in the registers are performing the multiply operation. The result is stored in the register 3. At the same time, the C value, third number, can be moved to the register 4. That is the second segment operation. And the third segment operation is add Ci to the product. The product is available in the R3 that can be added with the third number that is already stored in the register 4. Both can be added and the result is stored in the R5. So that is the segment 3 operation. So the computational task can be divided into 3 segments. The segment 1 performing the input AI and BI. Segment 2 performs the multiply and input Ci. Segment 3 performs add Ci to the product. How this pipelining process can be carried out is illustrated with the flowchart diagram. So here AI, BI, the storing of values to the registers. Until this, the segment 1 operation can be carried out. After that, with the multiplier, multiplication of this can be performed and the result is stored in the R3. At the meantime, the C value can be loaded in the register R4. So this is the segment 2 operation. In the third segment, the multiplication product and the third value can be added and storing result to the R5. So this is the segment 3 operation. How the overlap execution can be carried out with the pipelining process can be pictorially represented with the timing diagram. So the clock pulse number and how the segments can be carried out can be illustrated with the timing diagram. So here this is the clock pulse one. During that, the first segment operation of AI, BI loading to the corresponding registers is performed. In the second clock cell, the first number A1, B1 value can be moved to the multiplication and the third value can be input to the R4 can be carried out. At the same time, A2, B2 values can be loaded to the register R1 and R2. In the third clock cell, these product values can be moved to the next third segment. So A1, B1 multiplication plus C1 can be executed. So first number computational process can be completed at this clock pulse. At this same time, the second number can be at the segment 2 execution and third number can be at the segment 1 execution. So parallelly 3 instructions can be executed in a overlap fashion. So this is the pipelining concept. So here if it all a K segment pipeline with a clock cycle time of TP seconds. So with an n number of tasks, T1, T2, etc. Tn are required to be executed. So here T1 requires the total equal K into TP seconds, remaining n-1 task from the pipeline at the rate of 1 task per clock cycle. Then it is completed its time in n-1 TP seconds. So total clock cycles required can be calculated with k plus n minus 1. So if at all k is 3 segments and n is 5 tasks, 3 plus 5 minus 1, 7 total tasks can be 7 cycles can be required to execute the task. So the behavior of the pipeline can be illustrated with the space-time diagram. It is a representation of segment utilization as a function of time. So the horizontal steps displays the time in clock cycles and vertical axis gives the segment number. So this is the time space diagram of the pipeline example that we discussed. Next question is, what are the major characteristics of a multiprocessor? A multiprocessor in a single computer that has multiple processors, multiple CPUs can be employed. It is possible that the processors in the multiprocessor system can communicate and cooperate at various levels of solving the given problem. So more than one task can be executed concurrently at the same time with the help of multiprocessor system. The communication between the processors takes place by sending messages from one processor to other processor or by sharing a common memory. So two techniques can be used for communication between the processors. One is message sending, second one is shared memory. The general architecture of the multiprocessor can be more than one processor can be employed and these processors can share common clock and memory I/O. So here if you observe this architecture, processor is 8086, one processor, co-processor is 8087, two processors are connected and they are sharing the clock with bus logic, the memory and I/O. So this is the general architecture of multiprocessor system. What are the advantages of these multiprocessor systems? They are more reliable. If one processor fails, the other processors can take the load and they can continue for execution of the process. So this is known as graceful degradation. And multiple processes can be executed at the same time, which can enhance the throughput and performance of the system. And more economic systems are the multiprocessor systems. What are the disadvantages of multiprocessor systems? They increase the expenses and dedicated and complicated operating system can be required to communicate and coordinate various processes, and large main memory can be required to implement the shared memory concept between the processors. What are the major characteristics of multiprocessor system? A multiprocessor system is an interconnection of two or more CPUs with memory and input-output equipment. Here the processor means it's not the only CPU, it can be the input-output processor also. And it must be come under the category of Flynn's classification, that MIMD, that it can support the multiple instruction stream and multiple data stream. The multiprocessor system can support the parallel computing. So concurrent execution of tasks can be supported by the multiprocessor systems. And these multiprocessor systems support distributed computing. So the usage of network of processors can be supported with the multiprocessor systems. And they can support the supercomputing. So they can resolve the big computationally complex problems. And they can prefer the engineering and scientific applications. And this multiprocessor system can support vector computing. So it involves the usage of vector processors wherein the operations has to be divided into small and can be streams of operand can be supplied to these sub operations. So for example, multiplication can be divided into many steps and then applied to stream of operands. So these are the major characteristics of the multiprocessor system. Now how this architecture can be looked into. So here these are the 4 processors and can be connected, can have their own individual memory, and all processors are connected to the shared memory, so that the exchange of data, communication, synchronization can be carried out. Via the bus interface, they are connected to the off-chip components. So this is the layout of the multiprocessor architecture. Next question, what is a superscalar processor? So the superscalar processor can equip the processor with multiple processing units, so that several instructions can be executed in a parallel at each processing stage with the superscalar processor. So in the superscalar processor, multiplicity of functional units can be employed. So with this arrangement, several instructions start execution in same clock cycle and process is said to be use multiple issues. So such processors are capable of achieving an instruction execution throughput for more than one instruction per cycle. So more than one instruction can be executed at the same time with the superscalar processors. So these processors are referred as superscalar processor. So in these processors, multiple functional units can be employed. So generally, a single functional units can be employed in the computer, like single ALU, single arithmetic unit and logical unit, single memory unit. In these, some more functional units can be added so that they can perform some specialized task for execution. So if you consider this architecture for floating point processing, floating point unit, and for integer computations, the integer unit can be employed, so that the floating point addition, subtraction, multiplication, division carried out with floating point unit. At the same time, integer calculations can be implemented with the integer unit. So these type of processors are referred as superscalar processor architecture. And these are the references used for this video. So in this video, I have discussed regarding the question bank of module 5 multiprocessors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.